So in the Wild West, two horses pull a wagon down a railroad track. Okay, the track is in this direction as a vector. The first horse is pulling with this particular force in newtons, and the second horse is pulling with this particular force in newtons. Find the resultant force H of the two horses. Well, what I do remember from vectors is that resultant forces is just adding two vectors together. And so if I want to find H, I simply add these two together, which will give me 4, 23, and 2 is the resultant vector, H. So then it says find the component of H in the direction of the railroad track. Well, if we remember these two bits of information here, we know that if in the direction of B is given by this particular scenario here. So when I think about what is happening here is if I have my railroad track and there's two horses, they're not very smart, so the resultant is just off the actual track, let's say. They're fighting each other because maybe one's going on their side, but the resultant is just off the track. So this is H, and this is we'll call vector T, which is 2, 9, 1 from here. If I want to go the direction of the railroad track, that means if I take this particular vector, right, H, and I break it up into its components, I know that this much of H goes in the direction of the railroad track, and this much here will be perpendicular to the track. So I am looking for this vector here, and that is what this formula here will tell us in the direction of T. And so in order to find that, I'm going to do the dot product of H. So B part, I'm going to do the dot product of H dot T. And it took me a really long time to remember this formula, but it's always divided by the one that it's going the direction of. So it's always divided by the magnitude of T in this case. So I take my H vector, which I know is 4, 23, and 2, and I dot product with my T vector, which is 2, 9, and 1, and I'm going to divide it by the square root, the magnitude of 4, 2 squared, plus 9 squared, plus 1 squared, the magnitude of that vector. Doing the dot product is just going to be 8 plus 23 times 9 plus 2 times 1 is 2 over the square root of 86, and this I've already done in my notes as 217 over the square root of 86. And so that is the component of H. This much is going here in that direction there. C part then says find the component of H perpendicular to the railroad track. That's this one here, which is going to be this formula in this case. So now I want the cross product of the magnitude of the cross product of H and T over the magnitude of T again. Well, now I have 4, 23, 2 cross 2, 9, 1. And I want the magnitude of that over the magnitude of T is still the square root of 86. Finding the magnitude, well, if I want to find the first, well, I hide the first two numbers and I go 23 times 1, subtract 2 times 9. So 23 minus 18 is 5. And if I want the y category, I hide the y's, and as opposed to going 4 times 1, I do it opposite, so it's going to be 2 times 2. Subtract 4 times 1, well, that's 4 subtract 4 is 0. And then finally, if I'm looking for the z category, I hide the z ones, and I'm going to go 9 times 4 minus 23 times 2, so 36. Subtract 46 is a minus 10 negative over the square root of 86. And so now I need the magnitude of that. Well, that's going to be 5 squared is 25. Negative 10 squared is 100 over root 86. And so I get the square root of 125 over 86 is the component of the vector that is perpendicular to t. So h could break down into this part and that part. And that would be my h as components. So the last question here, the acceleration of a body. So the acceleration is equal to the resultant force, F, divided by the mass of the body. If you take physics, you may have seen as force is equal to mass times acceleration. That's what they're saying here. Find the so they've given you the formula. Find the mass is 300. Oh, the mass is 300 of the wagon. Find the acceleration of the wagon along the track, assuming no other forces. Well, that's acceleration along the track. So that means I have to take the value that is in the direction of the track, which is this force here. So I'm going to get 217 divided by the root of 86, and if I throw that into my calculator and check in my notes, I get 0.0780 meters per second squared. So we use our, or call our vectors, and we're adding vectors up to get a resultant force. We are using dot product, magnitude, and cross product to find directions in directions of various winds or perpendicular to various vectors. And then we have to come up with this formula from the words and use it to apply it to the values that we have.